All right. So hi everyone, I'm Jirka and I work here at Epify as a backend engineer. And we're really happy to welcome you at Epify and host the PyData Meetup. Now, my talk is gonna revolve about data and data sets related to AI. First, I'm going to start with some important and interesting data sets that have set the landscape for what is it today. Then we're gonna talk about the transformer architecture and some models like GPT and Llama and the data sets they were trained on. Then we're going to look at the text-to-image data sets, which is generally related to stable diffusion and other models like that. And lastly, we're going to have a demo. We're going to create a small data set, and then we're going to use it for a very fun downstream task. And I'm not going to reveal the task just now, so you have to be very patient, and then you'll see what it is. So first I'm going to ask you a question. What is the most popular data set? And I've tried to do some research on this, and there was one guy who was surveying all the research papers from the past 20 years, and then he figured out that the most mentioned and referenced data set is the MNIST, which is the Modified National Institute of Standards and Technology database. I'm sure most of you have seen it, and if you had some machine learning course at the university or you took some course at Udemy or Coursera, you've seen it. So it is a database of 70,000 handwritten digits. Each one is 28 by 28, and it has been around since 1994. And if you look at this, you're like, yeah, obviously there's like numbers from 0 to 9. But if I'm being really honest, I sometimes can't recognize my handwriting. So there's a story. I was taking an exam from the Mathematical Analysis 2 at Czech Technical University, and I was computing something very difficult. And I made one mistake in the computation. And it was because I couldn't read my own handwriting, so I wrote a plus sign. Oh no, it was a minus sign instead of multiplication. So I made a mistake by that. And now I want to ask you a question. What do you think this number is?
It's sure.
Yeah, it could be sure. That's an interesting point.
Upside down 5.
Also could be, someone could say 3. And honestly, I don't know. But the thing is, in the data set, you have to label each sample. So you have to choose whether it is 3 or 5. And nowadays, there are machine learning models that can get 99.91% accuracy on the test set on MNIST. But other research found out that there's 0.15% of the labels wrong. So the accuracy has a smaller error rate than there's the error rate in the testing set. So that's something to think about. And there are even some data sets that have 5% of the labels wrong. So now I'm going to ask another question. What is the data set that started the deep learning revolution? And the answer is the ImageNet. So ImageNet is a database of about 14 million images, and there was a ImageNet large-scale visual recognition challenge, which essentially means that you submit your models and they are tested on this data set, and who performs the best, is the winner and gets some money. But the interesting thing is that this challenge led to a machine learning model that is nowadays considered as the pivotal thing that has changed the landscape of AI, and it is the AlexNet. This model was introduced in 2012, and I'm also mentioning the names. Well, the first author, his first name is Alex. That's obviously the name of the neural network. The second guy is Ilya Sutskever, who is a former chief AI scientist at OpenAI. And the last author is Geoffrey Hinton, who is a receiver of the Turing Award, and he was PhD advisor of Alex Kryzhevsky. So all of these people are nowadays considered very relevant in the machine learning field. And so It was the only neural network that was submitted to the challenge in the year 2012, and they outperformed the second best model by more than 10%. And as of today, the paper has over 120,000 citations, and it is considered one of the most pivotal data sets for computer vision. And another thing to mention, the authors claim that the depth of the network was what's behind its success. So that's where the term deep learning comes from, because the network was really deep. So nowadays we have deep learning. Now I have some examples from the ImageNet, and I think the one that's most interesting is the cherry. Because if you look at it, there's obviously a duck on the picture, and still the label is cherry, so that's something to think about. Okay, so now I want to mention...
Sorry, what does a violet or purple mean? Where it's showing Dalmatian?
The correct labels are written as the first thing, and then there's the top 5 predictions given by AlexNet. So now I want to mention some data sets that are related to facial recognition, and I put them in because they're interesting in terms of some controversy. And celeb-A is a data set that consists of about 2,000 images of different people, about 10,000 identities. And let me show you some examples. There's also 40 attributes for each of the image. So if they have eyeglasses or a mustache or whatever. But the issue with this data set is that the distribution is very biased. As you see from the examples, most of the people have light skin color, and before the stable diffusion and generative AI stuff, researchers used to train models that could generate faces, photorealistic faces, and the generated faces copied the distribution from the data. So it was biased the same way as the data set. And it gets even worse. MS Celeb was a data set that was taken 5 years ago, taken down, and it was released by Microsoft, and it consisted of about 10 million images of faces. There was around 100,000 identities, and it was taken down because some investigation has shown that the Chinese government started to train facial recognition, which was tracking foreign journalists. So after the investigation, Microsoft just shut the website down. But if I'm being honest, if you try hard enough, you could find the datasets somewhere on the internet. So this was confirmed that one of the companies that was building the facial recognition for the Chinese government was actually using this. There was 10 million faces, and a lot of people, like journalists or artists, just were included in it. So yeah, it zoomed out to not show the identities of the people, but yeah, you can still get some of the images. And now we're getting to the transformer architecture, and this is the base architecture behind the LLMs we have today. And it was a very important step for the deep learning community. For the natural language processing, I'm going to use NLP from now on. It was very same meaning as the AlexNet was for computer vision. And why was it important? Before transformer, the natural language models were recurrent and sequential, which meant you have to process a sentence word by word. So you have to go word by word, which means the performance wasn't very good if you had long sentences. And the transformer had some improvements that managed to make the process to be able to be parallelized. And this unlocked the potential to scale the models. It's a foundation for the LLMs. So what was the trick that made it to be able to parallelize? And it's the positional encoding here. which actually encodes the information about the position of the word in the sentence. So instead of having to do it sequentially, you just encoded the information and the neural network understood it. So this is the transformer model as a foundation. And now I want to mention one of the interesting models that's still not the GPTs, but it's the BERT model, which was introduced by Google in 2018. And it's an encoder representations from transformers. But what's really interesting about this model was that it was the one that revolutionized the embedding concept. So it actually converts some text. It can be a paragraph or document, and it will give you a vector which represents the meaning of the document or sentence or whatever. And nowadays, I mean, if you go to some LLM or AI meetups, or you've heard about the retrieval augmented generation, and nowadays everyone's about the embeddings. So the BERT was very much before that. And it was trained using the book corpus and English Wikipedia. For the English Wikipedia, it's just a collection of the text from the whole English Wikipedia. They do some cleaning of the data, but it's not that interesting. Now for the book corpus, it was introduced in 2015 at the University of Toronto, which is interestingly the same university that created the AlexNet. And it consists of about 7,000 self-published books. So those books are ebooks. They are available publicly on the internet, and they created a dataset from it. It has around 985 million words. And it was used to train the BERT and also the first GPT. And now we're getting to the GPTs, which is the generative pre-trained transformer. And this model was introduced by OpenAI in 2018. And it has set up the AI community for the revolution we have today. And let me say that the first GPT had 118 million parameters. So remember the 118 million. So yeah, this was the first GPT by OpenAI. And now I'm going to talk about GPT-3 and the data that was used to train it. And you may be like, but GPT-4 has been out for a long time. Why don't you talk about that? GPT-3 is the last model they actually disclosed the training data set. So after that, they stopped disclosing the training data. And there are two reasons for that. The one they usually mention is that the competitive advantage. But the second reason is copyright infringement and lawsuits regarding to that. I'm going to touch on that later. So now let's talk about the data that was used for GPT-3. Most of the data was the common crawl, and I'm going to explain it in a bit more detail later, but it's basically scraped websites from the internet. So this is an open foundation that scrapes the data from the internet. And there's a lot of data scraped. They started in 2007, so there's petabytes of data. Now another data set is the web text 2. And it's really interesting how they created the data set. So they actually went to Reddit and they scraped all the outbound links to posts that had 3 or more upvotes. So they used this as a heuristic they used it as a heuristic that if people like the post on Reddit, then it should be reasonably good. And now there's two data sets called Books 1 and Books 2. Books 1 is very similar to the books corpus that I mentioned previously, but Books 2, they never revealed what was the data set, so nobody knows what was in it. And there are maybe some guesses that they just scraped some free ebooks from the internet. And now the last thing to compare with the first GPT, the largest GPT-3 has 175 billion parameters. So the first GPT had 118 million. So you can see the quick progress of the increase of the model size. Now let's look at Llama, which is a model by Meta. And You may again ask me, why not Llama 2? And I'm going to say they haven't disclosed the dataset for Llama 2. So they also claim that it was trained only using publicly available data. And this one has only 65 billion parameters with the largest model. And we can see the structure can be quite similar to the GPT. Most of it is also common crawl. Now, what is C4? C4 is actually a subset of common crawl that was filtered specifically to be higher quality. Now we can see some other data sets. So GitHub there's an open source data set of GitHub repositories. So they took the repositories that have some permissive licenses and used those to train the model so it can understand code. Very similarly, there's Archive and Stack Exchange. So Archive is for publishing papers and research. So if you use papers, they are usually high quality and very technical. So it's also good to have it in the training mix. And Stack Exchange is like the superset of Stack Overflow, which is like questions with pretty high quality answers. Now, Llama also used some dataset with books, but they took a different approach, and their books dataset is actually composed from two sub-datasets. One is from something called Project Gutenberg, and it's 70,000 free ebooks. And there's also books free from the Pile, which is an open source dataset, which is 200,000 free ebooks. Okay, so now let's talk about the Common Crawl, which was the source of most of the data. So it's a non-profit repository of web data that was established in 2007. They've scraped over 250 billion pages, spanning 17 years. So it's petabytes of data. But there's a lot of data, but the quality is low. So both GPT-3 and Llama used some filtering methods and the duplication to help shrink the data to have a smaller but high quality data set. And a great example is for GPT-3. The initial subset they took was 45 terabytes, but after they did the filtering and the duplication, it was only 0.57 terabytes afterwards. So you can see how much redundancy there is. And now some controversies. This is about a month old, but the New York Times actually sued OpenAI and Microsoft over the use of copyrighted work, because allegedly lots of articles from the New York Times were used to train the GPT models, and they obviously don't like it. And we still don't know the result, but this is going to set the landscape for the data for LLMs in the future, because if they say that the New York Times are right, then most of the data sets are going to have to be removed or changed in many ways. And there's a discussion whether if LLMs are trained on someone's data, if it's a good thing or no. There's some arguments that humans read articles and then they have the knowledge and compose it, but the other thing is humans can't read billions of articles, so this is very much discussable, and I don't want to have only controversies about OpenAI. So Meta was sued by the Authors Guild because the books that were used in training of the Llama models actually were also copyrighted. So what did Meta do? They stopped disclosing what data it uses to train the AI models.
So New York Times regularly steals from other reporters as well.
Yeah, it is what it is. So now I want to look at the text to image. It's not an LLM, but it's also pretty popular nowadays, Stable Diffusion, Midjourney, and stuff. So what did they actually use to train these models? And the answer is there's the LION, which is large-scale artificial intelligence open network. And I'm going to mention 3 datasets from them. So the first one is LION 400 million, and it was used to train the first Stable Diffusion model. And it consists of 400 million image text pairs, which are only in English. Now, afterwards, they created a larger data set, which is Lion 5 billion. And this data set consists of almost 6 billion image text pairs, which are filtered. But this one is multilingual, so it's not English only. And something they created is Lion Aesthetics. And this is a subset of the 5 billion data set. And they only included images which have high visual quality. And now you may ask, it's 5 billion images, how did they find out if they have high visual quality? And the answer is they obviously have a machine learning model that classifies whether the image is high quality or not. So they use this to filter the data. Here are some examples. You can notice that some of the descriptions are quite random, and usually what they do is they scrape some websites, and you have the image text in HTML, and it has the alt tag, so they use that for the caption. So, and there's also some controversies with the text-to-image models. And what I'm going to touch on is there has been research in generating different professions from the text-to-image models. And as you can see, they are very much biased in terms of skin. The skin colors are actually the same scale that is used by dermatologists. So you can notice that, for example, for architects, it's mostly gonna make him very light in skin, and for fast food workers, there's I'm not sure if you can see it. So there's a lot of bias, and the reason for that is obviously because the data set is biased, then the model is going to be biased. And another point is with males and females. So you can see that for the janitor, it was either man or ambiguous. So there wasn't a single female janitor generated. And for the social worker, it's mostly females. So yeah, it's just good to keep the biases in mind. And now finally the demo. So I'm going to have a drink, and so what we're actually going to build is a face recognition system. And first I'm going to go to Epify's about page. For those of you who haven't heard about Epify before, we are a platform for web automation and scraping. And we have a cloud platform, but what's really cool about the about page, there's a list of all people in the company with their names. And what we're going to do, we're going to scrape these faces and the names of all my colleagues, including me. Then we're going to convert it into vector representations. So for each person in Epify, I'm going to have a vector that represents their identity. And we're going to run facial recognition on my web camera. And I have a few colleagues around here, so they're going to come and we're going to test if it works or not. So I'm going to go to Epify. So this is what the platform looks like. But if you use it, you won't have this tab on top because that's for admins only. So we have something called actors, which are our cloud programs that can do reusable stuff. And what I have here is the Epify about page scraper. So it's really simple. It just goes to the page and extracts the image source and the names. So I'm going to run this and show you the results. So hopefully we're going to get all the faces with the names. And as I'm saying, I'm just gonna be using one picture for each of my colleagues. So you don't need that much data to do facial recognition. So now you can see this is just a JSON file, and here I have, so this is obviously our CEO, he's first, and this is the link to his photo. So all right, we have the data we need. So it seems there are 81 people scraped. And now I'm going to open VS Code, and I have two scripts here. The first one is going to fetch the images and convert it into the vector representation. So imagine that Imagine that you take someone's face, and at the end you're going to have a vector that represents his identity. So this is what the first script is going to do. So it will take a bit of time because it needs to run some models. And it works like that, that it will first detect the face, then it's going to use a machine learning model to convert it to representation. So if you've heard about embeddings, for example, for documents, now you can imagine that this is an embedding for someone's identity. So each of the vectors is going to have 512 dimensions, and it's going to be a compression of someone's identity. So yeah, it is running, and here is the folder with identity vectors, and you can see that there's a lot of people here already converted to vectors of their identity. All right, we're done. And now we're actually gonna try and run it. So let's hope nothing breaks. And all right. Yeah. So I'll ask a few of my colleagues to come here and let's try. Come on. So this is Marek Trunka, he's our CTO. So Vláďa, come here. Yeah, this is Vláďa, he's our lead Python developer. Maybe some other guys want to come, those two in the back. It's gonna find the closest person in Epify with the identity. So it's gonna be like your Epify lookalike. Yeah, Indra, come here. Yeah, come closer. Yeah, this is Indra. So also working as well. This is Kachka. Yeah, come closer, please. Yeah, so people can see it. Yeah, and here we have Natasha. Move a bit so it can be seen. Yeah, nice. So yeah. Thanks, guys. They deserve a clap. So, okay. And now I've prepared another slide for the people who like some latex stuff. It's a simple explanation of what I was doing with the identities. So imagine each person is 512 dimensions a vector, and all of these vectors are normalized, so they have the norm, the Euclidean norm is going to be 1. So then it simplifies to just scalar product. And if you want to do scalar product scaled on, for example, 100 other vectors, you can put it in a matrix, and then it's just simple matrix multiplication. And the result here is that we multiply this X will be the person who's looking into the web camera, and the M is going to be the vectors of people who are in the database. And then we will do the argmax, which will give us the index of the person who has the highest similarity. So what I had is that it always selects the most similar person in Epify for that identity. Now you may ask, you have an iPhone and you have the Face ID there. So does it work differently? And in a sense, yes, because for this verification in your phone, there is a threshold, which means that if the face is somehow disjointed or there's low light, it may just say that it doesn't recognize you because of the threshold. So what I was doing here, it's always gonna put some person there because it just selects the most similar one. But in your phone, it actually has a threshold under which it won't let anyone go. So that's the difference. And if you want some more details about this, we can discuss it later. And now will be the time for the questions.
So we will be showing again the schedule where is the link to Slido, so you can use it for asking questions. Yeah, at the very bottom, so slide.do PyPRG17. Feel free to ask. Cool, we already have at least 4. And you can also upvote an existing question if you really want to have it answered earlier, because we have a limited time of approximately 5 minutes. So feel free to also upvote, even if you don't want to put your own question. Yeah, so we have one of the questions. Feel free to add more. I will start with the first one. Do you know whether Stack Overflow is part of Common Crawl or entered the LLM training data in some other form?
Yeah, it's a great question, and this is definitely possible. So what was in all the papers that use Common Crawl, they always state that they perform the duplication process. So if they have some other data sets, they usually try to match it against it, and they're trying to remove the data that would be similar. So it's definitely possible that you have some Stack Overflow can be some post from Stack Overflow can be in the data set, for example, 20 times, and they have to duplicate it. So yeah, it can be there, and there are usually processes to remove it from it.
Okay, then we have another question with the highest number of upvotes. What are the reasons for a company to release a data set for public use? Is there a community of Czech companies doing so?
Public data sets.
Yeah, why to release it to public and where to find them?
I mean, generally, before the companies took over the research areas, it was the universities releasing the data set, so it wasn't companies really. So most of the data set we have today are just from universities, and they kind of have to or should publish it. For the companies, this is difficult because on one hand, it is something proprietary that you can use as a competitive advantage. On the other hand, if you provide the data set and you build a community around it, then you can become very much loved by the community. And for example, Meta, what is doing that they're releasing the models. For example, Llama 2 is open source with quite permissive license. The community likes that it's open source, so maybe for the community building, and also sometimes it happens that they make some mistakes and someone from the community will come and say this is wrong. And so the power of open source is more in the community. And yeah, it depends on what you're trying to do. If you're doing some competitive stock trading, then I wouldn't release the dataset.
Okay. There are 2 questions. I'm not sure if I understand what they mean, but let's skip them. So what's Epify's go-to approach to handle personally identifiable information in production model training pipelines?
Well, if I'm being honest, Epify doesn't train models that would work on any like personal data. So if we use AI models, it's like most of the time we were using, or nowadays we use LLM APIs. So we will not train our own models. We will just use some APIs, for example, the OpenAI. So yeah, the issue with personal data doesn't arise really.
There's another question related to your demo. Does increasing the number of persons in your demo dataset affect the recognition performance dramatically?
Well, the actual computation is quite fast because it's just matrix multiplication. But in the example, we are only using one picture of each person, and that is usually not enough to get a extremely good representation of someone. So it wouldn't be, if you added more people, the precision would be lower. but you can improve it by if you had more images of the same person, so you could get a better representation. For example, if you're creating the Face ID, it forces you to turn the camera to get more angles, so you get a better representation of someone's identity.
Okay, there's another question related to the filtering of data sets. How some specified model can be trained by large one? What is the mechanism of cutting off not needed data?
Yeah, this is interesting. And what they usually do, they have a high quality data set, which is a reference, and then they train a model that classifies whether, well, the model wants to, okay, let me rephrase it. Imagine you have the common crawl data set, which is very large, and you want to filter out the high quality data. So what you're going to do, you're going to have a much smaller but high quality data set and train a model that tries to select stuff that is in quality similar to the small high quality model. So it's again machine learning. So you have a small data set with high quality, and a model is used to filter out the data from the large one by trying to be similar in quality to the small one.
Thank you. There's another question. How can you use Llama 2 or any other model without knowing what data was used for training?
Well, I mean, from GPT 3.5 and onwards, we don't know what it was trained on, and people are using it like crazy. So the thing here is, and for example, the Llama 2, it's still open source and people can download it, but you don't know what it was trained on. So it could be considered that even though the model is open source, they're still keeping it as a competitive advantage, that the dataset is a competitive advantage. And generally speaking, there are some tricks that can actually retrieve the data it was trained on. So what you can do is you can copy paste, for example, half of an article from New York Times and put it into GPT, and it's going to create the rest of the article, and it may be the same as the article in the New York Times. So you this was used. So
And there's another question. I have to interpret it because it's hard to understand the original meaning, but I guess that it's about the technical stack used in your demo.
Yeah.
What's behind the scenes? Because there were some large APIs that are hiding the technology. So how does the tech stack needed for such a demo look like? If you could describe the hidden bits.
Yeah, I think I can show it. So it's quite simple. So for the recognition, it's only one library that is, it's actually by Chinese researchers on face recognition. It's called Inside Face, and it's a library that has tools for face detection, recognition, verification. And those authors are creators of one of the state-of-the-art models, which is called ArcFace. And that's the model that creates the vectors from the identities. So this is most of the work. Then I use OpenCV package for the video capture and some processing. And for the scraping, I used Epify. So that's it. There aren't any other hidden tricks or tools. And in the end, the computation here is just like matrix multiplication. So yeah.
Thanks. There's a question about legal aspects of the facial recognition.
Yeah.
So is it legal to use it? And does it differ for the security agencies and public use?
This is a very interesting point, and I'm sure most of you heard about the AI Act, which is being created by the European Union. And when AI Act comes into play, it's most likely going to prohibit all facial recognition. And another interesting thing, in China, they already prohibited the facial recognition, but there's an exception for the government. They can use it still. So, for example, they prohibited using it for trying to find someone's like race or health state or social status from the recognition. But yeah, there's an exception for the national security of China.
And we are slowly running out of time for the question window. So one more is how about the vector embeddings of faces? How does it work? Is there a convolutional neural network or how?
Yes, exactly. There's a convolutional neural network. In this example, which I use, it's a ResNet 50. And actually, the process works that first there's object detection. So you will detect the face, then you will cut the face out. There's some pre-processing, so maybe some alignment. So if your head is sideways, then it's going to align it a bit, which is generally done using the eyes. And then there's the model which converts the image into the vector, and that's a ResNet 50.
So the last question is slightly about also the legal aspects, and this is it even possible to retract the data from a data set? In, for example, the New York Times case. Like once your data entered a data set, can you enforce the data set creators to put it away?
Yeah, this is an active area of research, and I don't think it's possible at the moment. But I know there are approaches that they're trying to do this. But yeah, this is very problematic. So this is one of the reasons why they're not disclosing the training data sets. So for example, if you heard about the French company Mistral, they're very popular with their LLM. So they also haven't disclosed the training data set because they don't want to get into lawsuits.
Okay, so thank you for the questions.
So yeah, that's it. Thanks.
Jirka will surely be available
Yeah, definitely.
for any further questions in person, and another round of applause for him. Thank you.
So let me say one last thing. We are hiring, so if you be interested in working in our beautiful offices, you can check out the jobs page. Thank you.